Hello, in this video you'll see how to use memory queues in C#, threading channels as they might be known to you. This is sort of purely practical. We will not discuss the theory, just specifically how to actually use them. Now, I will also mention that in some cases you might need to use other tools that are not in memory, that are specifically designed to handle large volumes of these messages that are received and then written and read. There is something to be considered about that, but if you just have a decent amount of volume, you want to make sure nothing goes wrong. You want to make sure it's all sort of safe in terms of memory and all the other arrangements. This is the way to go. This is specifically C#.NET 9, although other versions of .NET will apply to this similar arrangement. And in this particular example, we will have two types of updates on one type of record, but basically we're updating the price and the stock for those different products. So we'll have two different, or rather one channel, but two different kinds of updates through the same channel. Now, one channel, that is kind of the point of it. It can have different arrangements, and the point of it is to create that specific layout for the data that would come through that channel, so it is recognized what needs to be done, whether it's updated, added, or what needs to be updated specifically. In this example, we have this sort of implementation. This is just a simple console application, .NET 9 console application, C#. But let's start first of all with the producer. So we need to produce some updates and we need to have some kind of a record. So in the producer, what we'll do, we'll have a while, sort of unlimited while loop, where we'll create some random data for the price and for everything else, basically random price, and we will update the price. Now, in this one, we generate updates for the price. So if you have a system where you have perhaps one single record for something, in this case a product, but it could be something else, perhaps some kind of a player data or something like that, you would probably have different services, different kind of arrangements that would be sending data to update that data in the database. So this is kind of what it represents. We have, in this case, price updates, and then we also have the stock updates. Now, they both do take the same thing, that is the writer, the channel writer. We will get back to that once we are dealing directly with that. But basically, we just generate some data for the purposes of the example, and then we send it to the queue to be written, or rather to be, for those records to be updated with the update record, essentially. Now, if we go down to the bottom here, we have the product update. So this isn't necessarily the product model or anything like that. This is just the update. What we have here with product ID, which would be for any kind of update, whether we update the stock or the price, it will still be product ID because we need to find that product to be updated by its ID. Perfectly fine. Now, in this case, since we have a value set as integer on both price and stock, we can use simply the value. Now, if you would have, for example, something different, you would have price as decimal and stock as integer, you would want to have different values. So stock value, price value, you would probably want to still reuse the same channel. That is how we usually try to approach this. So it is kind of straightforward what is updated, what needs to be updated, perhaps separate message, perhaps separate type of update. In this case, for the purposes of the example, we only use a string on the update type, although usually you would want to create some kind of enumeration for those arrangements to have a proper update type. And in this case, it will be either price or stock. So getting back to the produce price updates, we have right here just a simple price. If we look at this one, update type price. So once this message is received, the system will know it is updating the price. The value will be the price. And again, you could do something like you have a price value and stock value, different parameters. If one of them is null, that doesn't need to be updated. If the other is not null, that needs to be updated. So you can have all kinds of different arrangements. However, do always be careful with such things. Make sure that it's not nullable in those cases, and make sure you test all these arrangements quite thoroughly, because this is relatively asynchronous. And if you have lots of variations, it can cause quite a few problems down the line. So in this case, we create product update. That's all good and great. Now, after that, what we do is we have this channel, this memory queue, and we need to write it. So we take that channel using channel writer. So we don't do it directly. We do not have a channel. We don't establish channel necessarily. We have a channel already established, but we need channel writer in order to write into that queue. So we use channel writer. This is coming from System.Threading.Channels. Channel writer, and whatever type of data it takes, that will be transmitted to the reader, and the reader will pick it up one by one, essentially. But to write it, we just use the writer, and we do write async. We also need to provide the token for cancellation. That is quite important. You do want to be able to cancel it somehow. A lot of times it will be sort of negligible. It will not be used that much, but it is kind of good to implement some kind of a way to deal with those cancellations. But it will work even if you just ignore it. You still need to provide the variable, essentially the parameter, but it can be sort of ignored. In this case, however, we can, since this is a relatively small application, we can cancel you can issue cancellation on the cancellation token, and that will also cancel the delay, and then it will also cancel a while loop, so the program will essentially stop. So we will look at both of those examples running later on. It's a relatively straightforward matter, but essentially what you need to have to send this request or message, whichever word you like to use, you need to have a channel writer with correct type that you're passing through. In this case, we have product update. We create update, construct the update record, and then we pass through update record, and that will be updated. Now, in this case, we have this sort of console write line, but one thing to note, just because write async works, it doesn't throw an exception or anything like that, this second line does not guarantee at all that the update actually worked. Where the error handling needs to happen is in the actual reader. So just to get back a bit, this is how we actually start to use it right here. We have channels, we have product update channel, and we have a writer. So we pass that writer essentially. But we can now go a bit deeper into this. We can look at the consume updates. Okay, so we have consume updates. So we will later take a look at the actual channels. So it's a relatively straightforward setup, but once you have it written, you'll need a reader. So reader can read at any time at its own convenience, basically. In this case, we just execute another method and it starts reading. and it will read for as long as there's something to read at some point, essentially, right? So at some point it will try and read. And that point will be determined by this token. So if it's cancelled, it will stop reading. That's it. This loop will end and it will all end. It won't work anymore, essentially. This is something to sort of look after quite carefully, because if it stops reading, well, it's a bit troublesome. Now, the good thing about it is this operation cancelled exception. So if we do cancel it, we can get this exception. Obviously, you send it to some kind of a logger arrangement, or better yet, most likely, if you have some circumstances that are foreseen, not unforeseen, but foreseen, you would probably have some kind of a notification to your admin dashboard or some arrangement like that to notify your system that it's been cancelled. So you probably need to restart the system, or maybe need to do something for it to work again, because obviously it stopped. Well, it probably shouldn't just stop. So we need to do something about it. That is something always to consider about these things. You need to make sure you know exactly when it actually stopped reading, because you can be sending updates and they won't be updating and you'll just not know about it. That is something very, very important to remember. The reading itself, it happens quite simply. We have this reader, and the reader basically gets the object that you pass through of the type that you declare in the channel reader. And that is the same type that you declare in the channel writer. So relatively straightforward arrangement. Obviously in this case it's quite straightforward because we're dealing with just program.cs in the same sort of file, same sort of arrangement, but you would separate these in different files and do all these things. Perhaps it would be static, perhaps it would be something else, but essentially it's all the same type of thing. The basis of it is that it's sharing that channel. Now in this project we have this channels. Channels is simply custom class that was created in this project. There's nothing more to it. It's not something generic. It is a custom class. So here it is, custom class. We create a channel, which is used for both writing and reading, obviously. We have the type for the channel. Now you need to declare the type, obviously, for the channel, and then you need to provide the type that you are passing through. You can make it a bit more dynamic than this, but generally that is the idea. So you place the same object in the writer, and you place, or rather retrieve the same kind of object in the reader as well. But in this case, we just have a static channel from System.Threading.Channels, product update channel. We create unbounded. In this case we create unbounded, so it is unbound completely. We just have it laying around, all good. I'm not going to get into the details, but we are using in this case create unbounded. And then we need the channel options, which is not a lot of them. In this example, you can always get deeper into these readers and writers, but this is a general use case that should be fine for most applications. And just to make a bit of a note here, if it is not fine in this sort of basic arrangements, most likely you should consider something like Azure Service Bus or Kafka or RabbitMQ, basically one of those completely different arrangements that have sort of messaging queue system, but not in memory, not just in your application, because this is more for basic purposes, but that is more for if you have those really, really large volumes. That is very important to mention. and depending on every different use case, that is something that you need to determine yourself or between your peers. Now, in this case, the options are quite simple. Single writer represents exactly what it says. If you say true, then the channel can only have one writer. So once one writer is added, another cannot be added. This can have multiple, many writers. And in this case, we set true to single reader, so you won't be able to attach several readers. Now, this can be obviously good if you don't want to have some confusion, if you don't have any sort of additional handling for concurrency and things of that nature. It can be a really great thing to have this option. But if you do, maybe consider having several readers. Again, depending on your needs and applications and all those things. But generally, just to recap, we create a channel. Channel will have readers and it will have writers. So getting back to the start of the application, in this case, we just have cancellation source token that's kind of applied everywhere. Essentially, when it is cancelled, the whole thing will stop. Obviously, in real world, you wouldn't do that, but for example purposes, and you can find the source code on Patreon, play around with it, see what happens if you set different tokens and different things, add more writers, add more readers. Once you set that single reader to false, see what happens then. You can also find on Patreon free courses on C#, on Blazor, full courses for relatively low subscription price, so you're getting a really good deal, and you're getting all the source code for all these rather difficult and tricky examples, including crypto and C# and .NET and SQL Server and all these other things. So basically, we just write to the channel. We use the writer to write. So we generate the updates, then we generate the updates again. Different kinds of updates, but updates nonetheless. This is just task run, so it's running in the background. We obviously do have some control of it still because we have this cancellation token. Although we will lose it in this case because it is commented, but that is this example. You can uncomment it, and after 10 seconds it will just stop. If you don't uncomment it, it will not stop. It will just keep going and going and going until you shut down the program. And then we start consume updates. So we start our reader, which will read all the things that these methods will keep on writing and writing and writing, and that will keep on reading and reading and reading. So just to launch it a bit, we can see quite clearly what happens here. So right here, very simple. It just keeps on writing and writing and writing, and it will not stop. We do not have the cancellation invoked. It will wait those 10 seconds, but essentially it will not stop because we do not have any sort of cancellation arrangement. Now, if I do uncomment this, and just to make this slightly quicker, let's do 500 milliseconds, which is 5 seconds. So for 5 seconds, it will run and run and run, and then it will stop. It will throw this exception, which is perfectly fine. Task cancelled. And that is the task cancelled that we looked at before. It is stopped, it's done, that's it. It will not work anymore. And with that said, we will conclude this video.